to the site. Although earlier I was talking to someone about their test, so every time that happens, this thing will just go dark.
Oh, yeah. Okay. The way this thing is formatted is really weird too, by the way.
So I think, because as long as it's going in the background, we can see what's happening. Should people appear? Fine. It was actually kind of nice.
Did people actually?
I had like someone show up and I talked to her for like 30 minutes and do stuff, and
Oh, that's good.
it just seems more convenient like coming to campus.
Okay.
Plus, if I discuss anything useful, I can point people at it. Like I feel like in the future, this should be the primary way of doing office hours because it scales in a way that our time does not. There's an online person. Okay. I don't know how to make them see anything. Here's our camera. They can see all of us, maybe.
Yay!
Let's see if I put them on, will they talk to us? Hello, internet person.
Hi, Mikey. I don't know if you can see me.
Hi. What's up?
Yeah, oh, yeah, you can see me now. Okay, cool.
Can I
Hi!
see you?
Can you?
Hey.
I can see me. Can you?
Yeah, I can see you. There's a few of us here.
Hello.
Hello, people. So what's up?
Just tuning in.
Okay, yeah, nothing's going on. We're sitting here. I'm going to show you your exam. You guys don't have questions yet, but
Not yet.
decide what is the most confusing thing, and then we'll talk about that.
Okay.
Like, decide what part you hate the most.
Yeah,
And
we kind of know about that because we know it's going to be on the final, what we haven't covered yet. So
what we haven't covered is the most confusing to you.
no, like stuff that like we know the topics that are going to be on the final, and like we know which of what we've covered so far. It's
Yeah.
kind of confusing. So I think we kind of know like the topic. We don't know like specific things.
Okay, well, we can talk about the topic. Sometimes just in exploring like the general topic, I think makes more sense. So you want to see your exam?
Yeah.
Well, do you know which version you took?
DVC for me.
A. Okay,
Yeah.
follow me and we'll find your version. I'm gonna be right back, you guys. Plug that back in. We'll be back.
Go ahead, it's not on. What was I gonna say? I kind of want to see my exam. Do you think he's showing the exam or like just like his exam, or just maybe like a key?
Oh, like the scores, yeah, probably.
Probably a key.
Yeah.
I kind of wanted to see my written part because I wanted to see if I got the power question right.
Yeah, I didn't get to the power question.
No,
Yeah.
for some reason my answer is 50%, like flat out 50. Wasn't anything else.
Oh, really?
Yeah, I think that's wrong. I don't know why.
Yeah, I'm gonna use practice power.
Yeah,
I didn't do
I don't
any
think
examples.
I don't think he's gonna put a lot on there though, right?
Oh, yeah, he said easy ones.
So I don't think we're gonna actually have to calculate it. It might be a little bit longer.
Mhm.
He might ask us like the concept of what it is. Ask him to redo the quiz question, the one that.
I got it wrong.
So usually power one with people who got it halfway correct are people who.
Yeah, I got like minus point.
The thing. Sometimes people didn't use the right standard error, or they did like.
Yeah, I think I.
Yeah, you'd have to ask him because he's gonna have all those.
Okay.
Thanks for giving him all those and stuff. So
Do you have the,
Okay.
the fill-in ones or just the multiple choice?
Okay, so I need to.
hello, Noel.
Hello. You have the
Okay.
multiple choice or do you have the calculation?
I mean, yeah. If you come in, I can show you, but I can't show you on the internet. Probably also because it's super easy. These here are on YouTube, so we are on record now.
Oh,
I
okay.
think it's private YouTube, so so we can be sort of raunchy.
You're breaking up, but you said you have the fill-in answers?
No, I don't have those. I can give you your score on them, but I don't have the papers with me.
Okay.
So do you want your score? Because I could like just email you your score. I think you just sent me an email.
I have my score. I just want to know what I got wrong.
Oh, what you got wrong? Yeah, you'd have to talk to D. He has them.
Okay.
We will have them by Thursday. I think I have some and Wendy has some. So it's kind of fun to figure out who has what. Also, there are 4 people. We're trying to figure out who the people are because we have 7 people who didn't turn one in, and we have 4 copies with no names.
What?
Yeah, so that's a fun mystery to solve. But those people will be getting emails shortly. And then we'll have to take writing samples and be like detectives to figure out who did what.
Oh yeah, our question.
Yeah, you guys think you settled on.
Well, we didn't really get at HSD. I know it was on the last quiz,
Yeah.
but do you mind redoing the problem?
What is this? Let me see.
This one, but I don't have the slide out.
Okay.
I thought I chose the B. I thought in the answer sheet I put B.
You'd have to look at the raw scantrons, which he would have maybe, and he's probably not going to want to look at them with you. I've never been in a class where someone said my scantron was marked wrong, and we found the scantron and it was actually marked other than what
Okay.
is on the sheet.
Oh my god. I just need the answer and I mark it. So I need to look with him again. Okay.
Yeah, but I doubt even he
Yeah,
would go
I
to
doubt
dig
that.
through those
Okay.
because they're never wrong. Like
Okay.
because the scantron machine, when it had trouble scanning, it would even tell you like,
Yeah.
oh, we weren't that sure, but if it
Yeah.
gives you a definite answer, it's pretty solid.
Okay.
Okay, so number 2 you're asking about?
Well, any of the agents.
Okay.
Thank you.
The one?
Yeah.
Oh, I need the.
Yes. Okay.
Yeah.
Sure.
I don't know what I'm doing with them. Dumping them. I guess at the end. Oh.
Is this your last office hour for the week before the exam, Mikey?
Probably, but I'll probably just do another one because screw it.
That would be awesome.
Okay, but also I think I'm running Friday, so I don't know how much I'm going to cover on Friday, but the plan is to try to do some crazy tour de force thing. It just so 16 to 17 of the chapter
I
15.
can pull that up really quick if you want it.
Okay, so do that and then I'll work through it. And you need midterm stuff. All right, do you know which version of the midterm you took? Okay, so far everyone I've talked to is taking it. So far, fine.
It's really hard. It's just like one of the things I just didn't want to go through it. I didn't Yeah, there's this one and then there's that one. Sorry. So there's the group. So I guess one would be it's cheap versus mid-range. So I guess one would be cheap and then mid-range would be two. You find a mean of all the cheap, which is 35.1 minus 34.6. Should I try and do it right now and see if I can?
Yeah, this would be really good. That would be best. Or will they give us actual value?
I feel like they would just give us a rating and then they'll figure it out. So then from there you just find a mean.
But it's always a B. Is that coming?
Well, yes, because I assume that this is really like a mean of one. So I assume that it should be that sounds
So
right.
maybe
Yeah, now we have to figure out the variance within over X. Okay, for this one, which one did we use? How do you figure out the MS within between those two places? That's the problem. Because MS within basically sum of squared within. SS within. The variance pool. So you're supposed to find the variance of the first one and the variance of the second over the group. I had it right, but I don't remember what we did. Yeah, I don't think I did good math. Ugh. I should have done this often. I mean, I told the on the test. And if I can study it, I didn't find it. Okay. Except I was 5 over 84. Physics. Yeah, and that one's cumulative, so I actually have to try. Did you hear the market physics going $45 billion?
Yeah.
At first I was like, billion? Like, I think billion, and my friend told me, like, it's billion.
Okay, yeah.
Okay, I realized I had the slides out the whole time.
Okay.
So he said like 15 and 16, so the top one, and then scrolling down to that one. And then the other tab is the quiz. Because it seems like the top part's pretty easy. I think my problem is the MS within
Mhm.
the finding like the standard deviation. Because it's like it's basically like a Z-test almost, just a different format, right? It's like X
Yeah.
minus X over standard deviation.
Let me see if I can pull up stuff on mine. I'm gonna turn off my video because it's loud. Also, it's weird looking at me, looking at things. Throws me off. So let's see, where are those slides?
This is a really cool idea, but like you guys sound like robots at certain points. Like it breaks up.
Yeah, it works way better when I'm at home because I have a much more stable internet connection.
Yeah.
But then people are coming to look at the midterms, which is mostly what's slowing things down. Like I sort of wish we didn't let people look at the midterms as extensively as we do, because we spend a lot of class time talking about the midterms, which is better spent, I think, talking about statistics. In a
How is it
statistics, I would put precedence of statistics over midterm arguments.
Yeah.
So HSD is just a difference over some standardized measure. So what you were asking about?
So I think my problem is the denominator.
Okay, so MS within divided by n.
Mhm.
So
Because MS is within is just the variance within that group. I thought it was just the one group. Because I didn't actually do the math yet for
Yeah.
one way of ANOVA, obviously. I just
Okay.
know what you have to do.
Yeah.
I just haven't done it. So I didn't actually I don't remember actually doing the MS within.
okay, so it's where is this? So it's the slide right above it. How are they? Or this is the. Oh, but the MS within here is just they're treating it as residual.
Achieve and then add it to the variance of the mid-range.
Yeah, because what they're doing here is, so I was actually showing this to somebody else. Let me see if I can show you on my screen, and then also Noel can see what I'm talking about. So I was explaining this. I think the way we talk about ANOVA is kind of weird in that we don't do what I like to do, which is explaining what anything means. Because we don't give you guys a very good common sense, here's how you can understand what's happening with ANOVA, which I think is really important to get why any of this stuff works in general. So I'm going to share my screen to Noel so you can see what's going on. So this full screen share should be fine. I'll move this back to desktop.
Yay.
Can you see things?
Yep.
Okay. So here is kind of why ANOVA works and in general what we're trying to do, right? We call it analysis of variance, but really all that means is we have a bunch of data points. Like when we do any sort of experiment, it's like a bunch of data flows in, and what you can start from is saying, if we know nothing about any of these data points, what can we do? Like if we just had all these points, we can do what we've always done. Like, oh, here's the mean, here's the standard deviation, and we can describe it like its spread or its variance. So what ANOVA says, okay, if we know nothing, then all of our data are removed randomly. We can calculate a mean, we can calculate a variance for the whole data set. But we know more stuff about our data than just what they are. We can say, okay, the next step is, we know these data points come from different groups. So here we break these, these three come from green, this is purple, this is blue. These are different groups of people. And so now that we have them in groups, we can talk about different sources of variation. So the general ANOVA the general variance is calculate a grand mean, which is just the mean of everything. And then the variance is, the deviation of everything, like we've done in the past. But there's different sources. So one being here, when we talk about within group variation. So why is that green data point different than that green data point? And why is that data point different than that data point?
Is there an actual answer to this?
Not really.
Okay. Then.
It's actually, that's actually the point. We have no idea. As scientists, as psychologists, we did something to group one that is whatever the group one treatment is. And for some unknown reason, they are not all the same. That reason, generally, we understand it pretty intuitively, oh yeah, people are different. But as far as a scientific explanation for this, we don't have any good one. We can't pin it down to this person had more coffee than that person, this person slept more. In fact, there's a million causes, but we lump them all into this within group or MS within. But I think a better language when we talk about it is MS error, which is this is sort of, it's noise in our measurement and we cannot account for why it's there. It's completely unexplained variation.
That's
So-
residual, right?
Yeah, we also call it residual in the case of within subjects or repeated measures ANOVA, and we'll get to why it's called residual there. But generally, this is like the leftover stuff. We have no idea why this stuff exists. Like the fact that this person is different than his group mean, or this person is different than his group mean, is completely unexplained variation. We just don't know what's going on. We just say it's happening. We have to deal with the fact that it's there. And the same is true for every, these purple people are different than their group mean for mysterious, unknown reasons. We can't explain any of this. But the next step is saying, well, what we can explain is, why is this group mean different than the grand mean? And the reason it's different is because of what we did to that group. So we can calculate, we can say, okay, this deviation of here being different than the grand mean, we can actually explain this difference. So that explanation here is the MS between groups. Like the variation that's due to the groupings is explainable variation. We have a reason why it's different. These things are lower because they're in group one. Like we put them all in group one and they gave us a mean that's lower than the grand mean. Same thing here, same thing here. These are above the grand mean. So when you look at, where's the ANOVA formula? I'll put up his slides again, which is, I think, the ones you were just showing me. Books, TA stuff. What lecture was that? Oh, your computer's gone to sleep. Because he has like one nice formulas page. That is 15, I think. 11. Where is it?
This is chapter 15.
There it is, this one, right? So that's what's going on here. We're saying, okay, sum of squares total, this is just all the variation, right? So every score from the grand mean, square them all so they don't sum to 0. And then you can start pulling stuff out of that and saying, well, what else can we explain? So this occasions, that's the mean minus the grand mean. So I think this is the group. Yeah, this is the group. So for each member of the group, you can take its group mean, subtract it from the grand mean. So that's the stuff we can explain. Like this mean is not the same as the overall grand mean because it's in group one. So we're saying take its, yeah, it's between. Between means sort of the explainable stuff. That's how we always think. That's how I like to think of it. So we can say that difference minus the grand mean squared, all that variance is explainable variation. I know it's there because of what we've done to the groups. And the extra thing,
one to explain.
yeah.
Okay.
And usually when you don't have repeated measures, like when you're in one group and you're in one group, that's the only thing we have. The explained stuff is the reason the groups are different. Everything else is randomness. But if we do a study where you do conditions A, B, and C, and then you do conditions A, B, and C, I can also pull out some more variation. And I can say, well, let's say your average is 10 and yours is 11. The reason your average is different from the overall participant average is because it's coming from you. So like you were really well rested that day, your average gets higher. She's super tired, her average gets lower. So I'm trying to pull out the stuff that I can explain and leave myself with the F ratio, which is MS, what do we say? Yeah, I always forget the language they wanted me to use. So MS between, which is really the explainable stuff, divided by MS residual or MS air or MS within, which is just, here's what's left, I'll have no idea why it's there.
Okay.
And as that ratio gets bigger, the F value gets bigger, which makes it easier to reject the null hypothesis. So that's what ANOVA is trying to test in general. We're just saying, can our groupings explain more variation than is completely unexplained by our data set? And if those two are very even, we should get an F around 1, which means our groups are just as informative as randomness. And if it gets bigger than 1, it's saying this is proportionally how much more we can explain versus how much is left unexplained within our data set. So what you're getting extra here is I can take each participant's mean and subtract that from the grand mean. And that variation I can explain not by anything that's important about my study, right? Like you didn't come in thinking that all people are clones and that now you're finding out they're not. We already knew that people are different, but we're just trying to pull out like this variation that's due to people being different is not interesting.